Hey, my name is Yuwen. I'm a PhD student at the University of Notre Dame. I work in human AI interaction. So this is my thesis proposal. I am recording the first chunk of it right now because I forgot to press the record button in the beginning of the presentation. So I'm going to talk about the background of my research, a little bit about the first project, and after I reach the point that I did remember to hit recording, I'm going to switch this video to the recording. So yeah, my research focuses on user interfaces, the design, the development, and real-world use of user interfaces in the wild. I really love user interfaces because I believe they are the medium to interact with some of the best tools and systems that humanity has ever created. So if we look at these examples on the left, we have the original user interfaces for Apple Macintosh. In the middle is the first mouse created by Doug Engelbart. And on the right, we have iPad multi-touch user interface that users can zoom in using multiple fingers. And the way we create user interfaces today, the life cycle for user interfaces is that first, designers and developers would create these user interfaces. After they created these digital products, they get sent out to the wild, and users from different walks of life will get to interact with these digital products through user interfaces. So if we zoom in a bit, designers would usually use design software like Figma or Sketch to create mockups for these experiences of using the interfaces. And developers would implement these design using front-end frameworks like React or Swift UI and Kotlin for mobile. And after these user interfaces are created, end users would interact with them on different devices for different services. Well, as a community, there are two observations we are seeing for this whole life cycle. For designers and developers, there are a lot of new AI tools that are created to transform this whole workflow that they already have. So tools like Lovable, Magic Patterns, and Visual.dev are emerging to not only support design development workflows, but also transform it. And on the other hand, we have computer use agents, we have new browsers that supposedly will interact with these user interfaces on the user's behalf to prioritize user goals. My thesis fits in this emergent trend, and I aim to answer two questions in my research. First is how do we amplify workflows in UI creation, especially with the emergent capabilities of AI models nowadays? And the second is how do we promote design ethics and promote end user agency within this new paradigm that we're seeing? So I've worked on four projects that fit into these general questions that I want to answer. So let's start with the first one. The first project is called Flowy. It is a tool that supports UX design decisions through AI-driven pattern annotation in multi-screen user flows. This paper is submitted to WIST. And now I will go back to the original recording of my thesis proposal. So enjoy. Okay, a lot of tools are just adopting this prompt to UI generation paradigm. So V0, Wizard, these are tools that takes in a natural language prompt and then generates some output on your behalf as a designer or a developer. So this is pretty much an automation approach. What we're doing with these tools is we're essentially replacing designers by taking away some of the works that they try to do. And I think, to me, at least as a user, sometimes I feel weird about this process. I don't know why exactly it is weird. So we went to talk to designers. So we conducted five interviews as formative studies with UI UX designers. We basically did an hour contextual interviews. We also did some testing with Wizard, and we used this methodology called retrospective analysis. Basically, we went into their previous design files, having them share the processes that they created these artifacts, and try to understand their workflow using this method. And it was done in November 2023, just for context. So it was a while ago, but I think the findings we got were still valid. So one thing that we really learned in this process is realistic design workflows is nothing like a prompt to output generation. It starts with understanding the project scenario by going through the product requirement documents your PM probably sent you, by going through the existing interfaces to contextualize your research, and by trying to figure out the desired user journey you're trying to create for your users. And after designers make sense of this complex, contextual scenario, they would try to find appropriate design patterns, which are essentially reusable solution for reoccurring problems through real world examples like apps that they have used and seen in the past, analysis of design patterns from resources online, and also their corporate design systems. So after they acquire all of this project scenario and design pattern knowledge, they would start designing interactive prototypes that, as we can see on the right. So all of these interactive prototypes would incorporate the context and also the knowledge for design patterns that designers have acquired. And a lot of these doesn't happen like in every project. A lot of these are knowledge that designers accumulated over time, whether it's in their company or in general, their understanding of design patterns. So a lot of this can be implicit. And one thing that designers brought up is it's really hard to turn all of this contextual information for the project and also design pattern knowledge and put it into a prompt. Because a prompt can be that long, or if you want to make your super long, but it's really hard to incorporate all of that information into natural language. And a tool like Wizard can probably help best in the sense that it creates interactive prototypes for you based on a prompt. But after you create this prototype, you're gonna get stuck into this iteration loop that uses natural language to improve on the output, and it's not precise, and it's sometimes frustrating in the way that you don't know what to expect at the end. So let's see. What we decided to do instead is to focus on the second stage. What if we can use AI not to help automate this third process, but help them identify design pattern examples better and help them understand design patterns better? Because we think there's a missing opportunity here versus a lot of tools that are already working on the third stage. And that is essentially the goal for Flowy. For Flowy, we want to support the second stage by helping them, by supporting their design decision-making processes and taking an augmentation instead of replacement approach. So designers throughout interviews also expressed their need for the focus on multi-screen user flow patterns, because individual screens only contain like a piece within the user journey, but a lot of UI UX designers' work is actually centered around this whole journey or this flow that helps the user achieve something. And also in Flowy, we want to design the tool so that it helps designers find the inspirations, but also understand why the previous design was done this way, whether this will work for me, what are the benefits and disadvantages for using such a design pattern. So let's take a look at how Flowy works. It starts with this page that shows you a gallery of user flow examples from existing apps that's categorized into different design features. And it will give you a little widgets over this user interface that you can hover over and see an overview of this design pattern that AI has annotated for you. It gives you like a quick summary of the benefits, the disadvantages. And if you're interested in seeing further, you can click on the detail button to bring you into a detail page. It's going to show you some related design that's designed for a similar problem domain, some analysis, which I want to highlight here, that brings you to an external website that has analysis articles on this design pattern. And then it has also the purpose, the advantages, disadvantages, and some considerations if you're designing for something similar. So we have, that's how it works. But underlying all of the interfaces, we had a whole pipeline to annotate design patterns, to find where they are and try to understand what they are using AI. How do we do that? We started with a segment anything model to identify the major design components on the screen. We also used OCR to scan the text on the user interfaces. And after we obtained these annotated screenshots, in parallel, we also have a knowledge base of design pattern analysis articles that we curated online. And we used embedding similarity search to retrieve relevant articles whenever we are annotating one screen. And these two components get fed into this huge pipeline The first one, the segment anything model, as we've said, detects what UI elements are on the screen, and then the knowledge base provide contextual information about the design pattern, so the AI model can understand both of these information and put together an annotation report that we can use to display on Flowy. So after we completed all of this, after we developed Flowy, we conducted a user study with 8 UI UX designers of varying experience, and we also had them do a mock design activity, just use while they use Flowy as a source of inspiration. I'm not going to get into a lot of details, but designers generally reported that Flowy was helpful in finding real-world design inspirations for them. It can help them understand design rationale better, and in general, making more informed design decisions when they are, creating these mockups. Some of the learnings that we got from this project is we only annotated for interaction patterns, layout patterns, and some other patterns. But designers really care about also product, business, and development considerations when it comes to all of these patterns. Like maybe the previous designer put this feature in to achieve a business goal, and designers right now have to guess what that is, but they want to understand exactly the purpose of that when seeing an example like that. And also designers prioritize visual learning. So the visual interfaces, screenshots were really more helpful than a lot of the text that we put in there, even though we try to make them really concise. So that's the first project. That's Flowy. It supports, as I said, design decision-making using design pattern knowledge annotations generated by AI. So it kind of takes a different approach than prompt to output generation. So let's move on to the next project, which is called Misty. Let's switch up the visuals a little bit here. So Misty is a project that focuses on UI prototyping through interactive conceptual blending. Misty is an acronym. It stands for Mixing Interfaces Through Semantic Transformation, plus Y because why not? It's done with my amazing collaborators during my internship at Apple last summer. So it starts with this observation of designing a mobile UI. When we're designing mobile UIs, let's say we have this work in progress interface on the right. And a lot of times, designers, developers, when they're designing something, they look for inspirations, as we've seen in Flowy. And what they do is to blend this reference inspiration into their work in progress to generate a new blended output. So here we took the inspiration's dark theme and also a little icon for each list item and create this new page as an iteration over the previous work in progress. So designers do this a lot. Let's see another example. I'm still working on this interface. I like this reference example of Apple Music, and I really like the listening to gallery here of an album cover, the title of the album, and the creator of the album. What if I want to merge this gallery or like sort of carousel view into the interest list that I have right now, just to switch up the layout a little bit? And we can probably create something that looks like this. So interests, an image that captures this the essence of the interest that you're talking about, the interest itself, and a small description. So just to try out a couple different alternatives. And essentially, if we take a step back, what we're doing here is we're doing what is called conceptual blending academically. We're taking work in progress, we're taking reference inspirations, and blending aspects of this reference inspiration into your work in progress to create iterations that potentially make more sense to your own design than the previous one. And there are a lot of tools that are designed to support conceptual blending and creativity support, but not necessarily in UI creation. And designing these interfaces already took me a lot of time when I'm trying to blend them. It only takes people longer when they are trying to write code for them. So Misty's design is exactly to support this process. I was debating whether I should do a live demo, but I think maybe it's a good idea to try at least. Okay. Let me bring this page up.
Could you please elaborate as to why you are relentlessly optimistic about our funding prospects?
Someone
Yeah.
himself, I believe.
You, I think
Uh,
I mute all the
I
audience.
think Ning is the host right now.
Just
Where's the-
trying to stay on
is
time.
it-
We can mute her.
Okay.
Okay, so like really lagging right now. I'm just trying to bring this browser up
There we
so
go.
y'all can see it. All right. Okay. Okay. So let me refresh. So Misty is designed as a canvas-based tool with a couple different nodes on them. One type of the node is the code render, which is essentially a piece of React component that gets rendered in real time. So if you want to make changes here, delete this, it gets reflected in real time. And this will be our work in progress. Let's say I find this example very interesting. I want to just combine these two together to generate a new iteration using the visual styles of this screenshot, but using still the data and the information in my work in progress. What I can do is to drag and connect these two together. And I believe the backend might be sleeping, so I just try to do that a couple of times because I'm on a free plan. Okay. So yeah, what it's doing in the backend is to take the screenshot, send an API request to GPT-4o, say, can you take the look and feel of this screenshot, blend it into my current code work in progress, and update the code and generate a new node. And as I believe the backend probably never wakes up. Oh, here we go. Okay. Let me try it again. So when we get response from the model, it's going to show up here in real time, so we know the progress of the current generation. But essentially, it does what I was telling you it's going to do. It takes this look and feel of the screenshot and blend it into the current code work in progress. It usually takes about 10 seconds to generate an output. GPT-4o has been giving me a hard time lately, so it takes slightly longer. But here we go. Essentially, it takes the content of the code here, which is the book list, and renders it or generate code and with the look and feel of the reference example you're blending in. I just also want to highlight the additional things that come together with this is also a list of semantic changes that the model did to the UI, so you can toggle them on and off each one. So for example, we can see that we changed dark to light theme here. We switched to a horizontal cart layout with images, added images to the layout, added shadows and padding. You can turn these on and off each one. The other thing I want to highlight.
Can you try toggle off one of those?
Yeah, right now it sends an API call to the
Okay.
model again, but it's going to work.
What was the, oh, never mind. I was gonna ask what was latest original, so it took that
Yeah, so this,
padding from the first one.
oh yeah, right.
It took the-
That's the weird part. Sometimes it does things like that, but the cool thing is you can always go back, change latest originals to my books.
Yeah,
So that gives you like a fallback mechanism. And then the other thing I want to highlight is, let's say I really like the documentary prehistoric planet and description layout here. I want to do the same for my book. What I can do is to crop that out, drag and drop it onto a corresponding screen. Let me zoom in a bit more. Drag and drop it onto the corresponding section of the screen. So you can say, let me blend this section of the reference example into this section of my screen, apply the layout and the content, say add category and description for each book. and then blend it in. So this basically provides you with a bit more granularity over what gets blended in, which aspects of this gets blended into what area of the work in progress. So let's just give it a couple more seconds. For context, when I was demoing this at the end of my internship at Apple, the demo crashed like 3 times. I'm really glad it's working today. So if you do that, and the cool thing about this is these models have world knowledge of these books. So if you look at the description, brief history of time exploring cosmology, theoretical physics, and the universe, it actually matches the content of the book. So this basically, yeah, gives you a way to prototype these UIs using inspirations a bit faster using direct manipulation. All right, let's go back to our slides. That was the demo. I believe I'll have to skip to the next one. So if we look back at the design goals that we had, it's really to blend these inspirations using familiar input modalities, meaning direct manipulation. You can also blend in human sketches into your work in progress, and you can use drag and drop as a very natural way to interact with the system of natural language prompt. And somehow the slides got broken, but the other two I will talk about is really, it was a canvas-based interaction. So you have iterations represented as nodes, which fits the iterative nature of UI prototyping. And the third thing is we try to have widgets that supports more granularity in the blending of these user interfaces. So after that, we conducted a 1-hour first-to-use study with 14 front-end developers at Apple. Each participant was instructed to use Misty on a set of defined tasks first, and then explored using the system freely on examples of their own. Here are some of the results that they were able to get. So you can see for each output, so each output is generated by one participant. You can see that even using the same examples, it generally follows the instruction of the examples, but there's slight variation each time the model generates an output. So it gives you a little bit more, flexibility or a little bit uncertainty each time you generate, which the participant found was the fun part. And I want to highlight on the bottom row here, you can blend in human drawn sketches, take a screenshot, upload it to our system, and then you can blend that in, generating the output that we can see here. So I just want to highlight two findings from our study. The first is participants found it really helpful in kickstarting creative explorations. And P4 said Misty will add productivity boost to their work by 20 to 30%. P10 said Misty can automate tasks that would take 20 to 30 minutes to do otherwise. The other thing participants mentioned is they really like the way that Misty supports refining iteratively and visually using all of the nodes that we have. But a caveat is not all iterations involve blending. Sometimes they want to just use a natural language prompt to iterate on the output that they have without necessarily blending in a new example, which is something we're going to be working on. So I want to come back and highlight how Misty amplifies the existing workflows of designers, developers, and prototyping. So Misty supports existing workflow of inspiration borrowing. You are essentially already borrowing a lot of inspiration from the things that you look at. We just kind of amplify what designers, developers are already doing there. As I said, it's a canvas-based iterative refinement tool that gives you a lot of nodes that represent different iterations for your exploration. And at the end, we have these semantic groups of changes that the model made, and also you can blend in semantically meaningful aspects of the inspiration, which essentially supports semantic level editing instead of manually typing all of the detailed code. So that is Misty. And if we come back to the landscape we had just now, these two tools support the cognitive processes in UI creation, as I said. Flowy supports decision-making and understanding of design patterns. Misty supports the iterative rapid prototyping processes.
that borrows inspirations from existing examples using direct manipulations. And now we're moving on to the second part, which is supporting design ethics and end user agents. We're going to start with this project Crepe, which is a mobile screen data collector using graph query. It is a tool that, as I said, focuses on end users. And it's a tool that I want to emphasize that supports mostly data. Now, what I mean by data, before I go into that, I'll just introduce my collaborators real quick. This is a very multidisciplinary team, and we've been working on it for a long time. So we want to help participants understand their screen data. For example, every day when we scroll Instagram, we're going to see these ads popping into our story. Do you know what ads gets to, sent to you every single day? You probably have like a vague idea, like these are the brands that I usually see. But it's really hard for you to see exactly what ads you are seeing every single day. And Instagram allows you to see it, but for a lot of platforms, they don't give you that information. And Instagram actually hide it really well. So it took me a little second to find all of the ads that gets promoted to me. So what we want to do with Crepe is to collect this data so that we can raise the awareness of participants, like help them understand what is going on their screen, what data they're seeing every single day. We also want to use this data to do potentially algorithm auditing. And we can also train personal agents once we obtain this data from the users' phones. So screen data is really useful in these different ways. And there are many other ways that I probably didn't mention here. So there has been some existing work on collecting data from participants' phones, like collecting screen data. One is at Stanford, it's called Screenome project. It essentially takes screenshot every once in a while, like a 30-second interval on your phone, and they construct this sort of interval-based map or graph of the screenshots that they took from you to understand every day what your pattern of mobile phone use is. But the problem with this approach is, since it's only capturing screenshots at an interval, you're missing information between these intervals. And also, when you're capturing a whole screenshot of the screen, you are including a lot of unnecessary private information that the user probably don't want you to collect. So for Crepe, we want to collect the data, but we want to collect it when the target data shows up. So collect the target data only when it shows up. And the second thing we want to do is to only collect the target data. So let's say we have a screen like this here. We are collecting the sponsored ads Instagram stories promotes to you. We want to collect only that piece of information that says Apple. And we only want to collect that when it shows up. How do we do it? Let me introduce you the technical details of Crepe, which uses what we call a graph query that parses the structure of the user interfaces. So for the example we're seeing just now, we can imagine an underlying structure of this user interfaces that looks pretty much like a tree. A tree basically contains the information of elements on the screen and their parent-children relationships. And we can obtain this UI snapshot using Android accessibility services. And what we did is not only we took this UI snapshot, we also augmented it into a graph, as we're seeing right here on the bottom right. The graph contains not only the parent-children relationship, but also the screen UI element information and the element's attribute information. So if you want to take a look here, for the button, it has a class of button, it has text of sponsored, and it has relationship between with other elements on the screen. So first we, as I said, augment this UI snapshot into a graph. And we created, and when the user clicks on, specifies a piece of element they want to look for, what we can do is we created this query language that basically identifies the target element and only identifies the target element. There's a lot of details I'm not going to cover here. But once we have this query element, we can execute it on the UI snapshot and find the element that we want. So let's probably just dive into the graph query a little bit. It basically specifies, we have to read it backwards here. In the package of Instagram, an element that has the class name of text view. Okay, here we go. The class name of text view is our target element. And we would want to look for the text view that is above the element that has a class name of button, has text as sponsored, and in the package of Android. What it says is we're looking for a text view that is above the text view that says sponsored. We want to add this sort of anchor, which is the sponsored text for our target data, because the target data can change. We cannot say we're collecting this piece of information that says Apple because every time it changes. So we're anchoring against another element that is close to it on the screen. So essentially what we are able to do with this graph query is when we're executing it on a UI that has the target data, we can identify this target element and collect that piece of information. But when we execute it on the UI that does not contain our target data, it's not going to give us any result. And we did some evaluations of this tool. It performed decently well. So we did evaluation on 3 different apps, Instagram, Uber, and Chrome, for different collection tasks. The overall F1 score is 96%. And we're working on some edge cases that it does not necessarily cover all the time. So now that we have this tool, it basically provides us with a data platform, as I said, can help us increase the awareness of the user for what they're seeing on the screen. It also helps us to audit the information, the algorithm that promotes ads to the users on Instagram. But we can also, one potential use case is to train a personal agent by understanding the data that shows up on the screen. What I'm saying is we have this potential use case that we've been thinking about. If you are an Uber driver, what we know is the tasks that you are doing every single day, but the missing information is what tasks gets promoted to you when you are waiting for the next ride. Uber doesn't provide that information to us. If we can obtain information on that, we can help them making sense of their working conditions. Say, potentially you are right now in a busy area, expect trip soon, or say, right now you are not in the ideal area for what type of work you generally want to receive. You probably want to drive to that section of the city so that you receive tasks that you would really usually accept. So that's what we expect Crypt to do.
Can you say that example again? Sorry.
Yeah, I didn't explain it very well. But essentially, we are trying to help Uber drivers make sense of the tasks they are getting promoted every day. Okay. And then we want to train a personal agent that kind of predicts what types of tasks they are receiving and guiding them to the area of the city or the time of the day that they will get more ideal.
The tasks that they would like.
Yes, okay. Tasks they would like. That sounds tricky, but
it does.
We think it's possible to do it.
Okay.
Essentially,
without Uber participating, without thinking it that way.
That's the point. That's the point. So we're like acting on the driver's behalf against these platforms because the platform always wants to optimize for the global, efficiency of their algorithms of drivers providing rides on their platform, but that doesn't necessarily go well with drivers' individual desires and personal considerations. So essentially, once we have this data platform, we want to collect data to support all of these different tasks. And that is great. That is a data platform that we're building. And we're going to open source this so that researchers can collect data on their own. Next up, we're moving on to the last project, which is called Dark PETA. It's exploring end-user empowerment interventions for dark patterns in UX. It received a Best Paper Award at CSCW last year, and it was done with my amazing collaborators from Notre Dame, Cornell Tech, and Virginia Tech. So dark PETA really focuses on this phenomenon of dark patterns that all of us are probably have encountered with but never realize it's there. So dark patterns is a user interface that has been carefully crafted to trick users into doing things with a solid understanding of human psychology, and they do not have necessarily the user's interest in mind. Just to provide you with an example, when you go to websites like Amazon, you notice that there are two buttons here. One is add to cart, one is buy now. And they intentionally designed these to be in different colors. Do you know why? Because a more prominent color, the more bright orange used on buy now will unconsciously lead you to click on it more likely versus add to cart. And what happens when you go to add to cart? You see all of the items that is in your cart, you realize you're spending too much money, and then you start to edit and remove stuff from your shopping cart. And that's not what Amazon wants you to do. So there has been a lot of studies of dark patterns in academia in the past. I just want to highlight, there are papers that understand dark pattern as a phenomenon, understand the attributes of dark patterns, and understand dark patterns from the perspective of end users. So there's this great quote that they had: "I'm definitely manipulated even when I'm aware of it. It's ridiculous." Because that's human psychology. Everyone is subjective to it. So there has been a lot of interventions we have tried to impose on dark patterns. First one starts with designers, because they are the ones that are asked to create them in the first place. A lot of efforts have been focusing on design ethics, education, advocacy, to tell designers don't do this, but they probably have to still do it because of business constraints. And also there's effort from the policymaker side to impose regulations and enforcement on dark patterns. So, the famous example is the cookie banner for European Union that has to ask you to share your cookies whenever you go onto a website in European Union. But our project is really centered around end users. Well, a lot of effort has already been focused on end users' part to help them be aware of dark patterns and to empower them against dark patterns. And our project exactly fits into this profile. Well, one thing I believe is users probably don't know what they want, but a lot of us as users and users in general know what they don't want. What if we just respect their agency, respect their ideas, utilize this agency to help them customize their own interfaces against dark patterns? And that's a very straightforward thing. And that is why we designed Dark PETA, which is also an acronym, stands for Dark Pattern Intervention for Transparency and Accountability. We designed it as a technology probe, which essentially means we are trying to use this tool to understand the user needs instead of meaning it to be very useful in real world in the long term. And it looks something like this. Let me show you how it works in reality. So when you go onto a website with Dark PETA installed, you're going to see this banner on top saying, "Hello there, dark patterns detected." You can click on show to highlight the dark pattern on this website. In this case, it's the buy now button. And we provide a panel to describe why this is a dark pattern and the potential impact it's going to have on the user. And you can take actions. You can select from a list of options that we provided. And right now, well, you can't really see, but this is still orange. You can select no action, which is just leave it as it is. You can hide the button altogether. You can change the color of it to match the add to cart, or you can add a fiction, which essentially whenever you hover over buy now, it gives you a pop-up saying, "Are you sure?" So let's say here we just select change color, it goes to the same yellow color as the add to cart. And then whenever you have Dark PETA installed on your browser, it's going to look like this way. So yeah, the design of this is really focusing on two aspects: the awareness of users to the dark patterns and the action they can take against these dark patterns. And after we designed and developed this, we made sure it ran for 2 weeks. And we did this 2-week technology probe study by recruiting 15 participants from all over the world. And we asked them to install and use Dark PETA on their personal device, and then asked them to log diary notes when they had something to share. And there are a lot of findings that we found. I just want to, for the sake of time, highlight a few of them. First one is we learned that interventions are contextual, personal, and dynamic. We understand that it's contextual, like we probably want different interventions for similar dark patterns in different scenarios. It's personal in that me and you probably don't share the same idea for intervention for the same dark pattern. Even for the same person, we learned that dark pattern interventions can be dynamic through different scenarios. Like, I think this quote, I don't know how I hear, participant 14 said, when I want to focus and when I just want to have fun or just relax, I think they being the intervention desired changed based on what I want to do at the time. And this one is talking about Netflix autoplay feature. Like if I'm just showing, I probably want to have it autoplay and then just mindlessly click into it because I don't want to think. But when I'm working, I don't want to open Netflix and get drawn to it and spend 2 hours watching episodes. So darkness is not purely objective. And that is why it kind of matches our goal of using an end user driven approach, because users have their own agency, they have their own personal considerations. And that is why we want to empower end users against these dark patterns instead of enforcing one single rule or one single standard on all of the users. So if we take a step back, why do we do all of this? So the grand goal of HCI is to make technology human-centered. That's why we have special roles and positions in the industry that we set as UI UX designers and developers that create digital products and help end users achieve their goals through these digital products. And this is the exact same like life cycle thing. If you didn't realize, this is just different visuals. But throughout the whole process of this industry growing and digital products being pushed to users, one thing that happened is designers now have this dictatorship over the digital products that end users get to enjoy every day. If I don't like something, I'll just deal with that. Designers can push whatever they want onto your interface. That is why we have 10 pop-ups on their websites when we go into. Just try to look for a baking recipe, but they hit you with 10 irrelevant ads. What we're trying to do with DarkPeta is really to support these end users to get more informed and align their values and interests to what they want onto what is actually showing the screen and how the screen, the UI is designed, and help them taking action to escape from manipulative design patterns that they might get faced. And we think this approach, as we said, this end user driven approach is really in complementary with UI UX designers and policymakers because they can work in parallel all together to address this issue. And we're really happy to see there are some real world applications that take the ideas in DarkPeta and make them real. The first is Arc Boost that was launched in May 2023 that helps users customize any website. I just jump here because it's moving. Safari distraction control can help you hide elements on the screen that you don't like. And A/B testing is a feature provided, or like a whole website provided by Mobbing that curates A/B testing examples and results that designers have launched in the past. So that is DarkPeta. These are the 4 projects that I've worked on, and I'm supposed to propose a new project, so I'm going to spend 2 minutes on it. So the thing about modern day AI that a lot of my projects have used is it's based on neural networks, and it's opaque in the way that we don't understand why it's working, why it's not working. So in order to help users better, to help designers, developers better using AI, I think it's probably a good idea to understand what is happening underneath all of these, neurons connected together, activation functions and everything. And there has been this new direction in interpretability research in machine learning, which essentially uses a structure called sparse autoencoders to understand the latent vectors that gets outputted by a layer in this neural network. So what we can do is to feed the latent activation embeddings into a sparse autoencoder, which is an autoencoder but has a sparse latent space that is very big and is consistent mostly of zeros and ones. Use this sparse autoencoder structure, we can magically identify human interpretable features from the latent space. And each of the features that I show here on the right is taken on this website called featurelab.xyz. And each of them correspond to a neuron in the latent space of the sparse autoencoders. So just for more context, sparse autoencoders would turn a embedding of a bunch of floating numbers and then turn them into this latent space of neurons of zeros and ones. And that is where the sparsity comes from. And the ones are actually corresponding to the human interpretable features that came from the input embedding, if that makes sense. So what we want to do is to really use this on user interfaces. Can we use a sparse autoencoder to understand the embedding model and multimodal embedding model like CLIP to understand the human interpretable features of user interfaces from screenshots? And that is what I propose to do. That is a very high-level overview, but it's mechanistic interpretability of UI generation and understanding using sparse autoencoders. And that is what I want to achieve before I graduate. And that's everything.